The ground trembles. It is a subtle vibration felt in the chest before it's ever heard by the ear. From the dense thorny scrub of an Indonesian island emerges a creature that feels like it's walked straight out of a time machine and into the modern world. It drags a tail thick as a tree trunk, its skin armored in osteoderms that act like chainmail, and its eyes scan the horizon with a cold, calculating intelligence. This is not a dinosaur, though standing next to one might make you feel like you've traveled back to the Jurassic. This is the Komodo Dragon. For centuries, there were whispers in the logs of sailors about stories of land crocodiles and fire-breathing beasts that roamed the isolated islands of the Sunda Shelf. We treated them as myths until 1910, when the Western world finally confirmed that dragons are real. But the reality of the Komodo dragon is far more terrifying and far more sophisticated than any fire-breathing monster of folklore. They are the largest lizards on Earth, capable of reaching lengths of over 10 feet and weighing as much as a large sumo wrestler. They are the undisputed kings of their domain, apex predators that hunt with patience and brutality that is unmatched in the reptile kingdom. But looking at the Komodo dragon is deceiving. We see a sluggish, lumbering giant. The reality is a biological machine, engineered for one specific purpose, such as the infliction of catastrophic damage. They possess a weapon system so complex that scientists have spent decades arguing how it actually works. Is it bacteria? Is it venom? Or is it something else entirely? How does a cold-blooded reptile possess the intelligence to recognize individual human keepers and even engage in play? A behavior we usually reserve for dogs and dolphins. The biology of the Komodo dragon is a masterclass in the evolutionary overkill, a story of an animal that didn't just adapt to its environment, but conquered it through chemical warfare and brute force. Evolutionary origins. To understand the Komodo dragon, we have to look at the strange phenomenon of the island biogeography. Islands are evolutionary laboratories. When animals are isolated on islands with limited resources and no competition, small animals tend to get big, known as island gigantism, and big animals tend to get small, also known as island dwarfism. The Komodo dragon is the ultimate example of the former. Scientists believe that the ancestors of the Komodo dragon evolved in Australia roughly 3.8 million years ago. Back then, they were part of a lineage of massive monitor lizards, like the extinct Magnalia, grew to be twice the size of the modern Komodo. When the megafauna of Australia went extinct and the waters rose, the Komodo dragons were left isolated on a handful of islands like Komodo, Rincia, Flores, Gili Motang, and Padar. On these islands, they faced no competition from lions, tigers, or bears. They became the apex predator by default. This isolation allowed them to retain a body plan that has remained virtually unchanged for millions of years. While mammals were evolving complex social structures and high-speed metabolisms to survive the ice ages, the Komodo dragon doubled down on the reptile blueprint. They proved that you don't need to be warm-blooded to rule the world. You just need to be big enough to eat everything else. They are living fossils, a glimpse into a world where reptiles still held the crown, surviving mass extinctions to stare us down today. Anatomy of a shredder. If you were to look into the mouth of a Komodo dragon, you might be surprised. You wouldn't see the jagged, snaggle-toothed grin of a crocodile. Instead, you will see what looks like a gummy smile. The teeth are hidden, encased within thick, fleshy gums. But this is a deception. Hidden within those gums are 60 curved, serrated teeth that are essentially steak knives. The teeth are laterally compressed, meaning they are flattened from one side to side and possesses serrations on the back edge. This shape is not designed for crushing bone like the teeth of the T-Rex or hyena. It is designed for slashing. The bite force of the Komodo dragon is surprisingly low. A house cat has the bite force relative to its size that rivals the dragon. But the dragon doesn't need to crush you. It applies a technique called grip and rip. It bites down and then uses its massive muscular neck to pull back violently. In 2019, scientists discovered something insane about these teeth. They noticed that the tips and the serrated edges were stained a deep orange. Chemical analysis revealed that this was a concentrated coating of iron. This iron pigmentation hardens the enamel, keeping the serrations razor sharp and resistant to wear and tear. It is a biological metal plating. To compare this, beavers have iron in their teeth to chew through wood, but finding it in a carnivorous reptile is unique. Evolution essentially gave them metal-tipped saws for teeth ensuring that when they bite, they don't just puncture, they eviscerate. The bacteria myth. For decades, if you watch a nature documentary about Komodo dragons, you were told a very specific horror story. The story went that the dragon's mouth was a cesspool of deadly, rotting bacteria. We were told that the dragons would bite its prey, and even if the prey escaped, the bacteria would cause rapid sepsis, or blood poisoning, killing the animal days later. The dragon would simply track the dying animal and eat it at its leisure. This theory was popularized by Walter Offenberg in the 1980s. It painted the dragon as a dirty, passive scavenger that used biological filth as a weapon. But in the modern era of microbiology, this theory fell apart. Scientists led by Brian Fry at the University of Queensland decided to test this. They swabbed the mouths of Komodo dragons and analyzed the bacterial load. What they found was shocking. The mouths of the Komodo dragons are actually surprisingly clean. In fact, they have lower bacterial counts than the mouths of lions or Tasmanian devils. They're certainly cleaner than the mouth of the human. Komodo dragons are fastidious groomers. After they eat, they spend time wiping their faces in leaves and licking their lips. They don't walk around with rotting meat hanging from their teeth. So, if the bacteria isn't the weapon, why do water buffaloes die of infection after a bite? The answer lies in the environment, not the dragon. Water buffaloes are not native to these dry Indonesian islands. They were brought here by humans. In their native wetlands, when a buffalo is threatened, it runs into the water. On Komodo Island, the only water available is often stagnant, feces-filled watering holes. When a buffalo is bitten and runs into the dirty water, the wounds get infected by the water, not the dragon. The bacterial bite was a myth born of ecological coincidence. The Venom revelation, chemical warfare. If bacteria isn't the secret weapon, what is? In 2009, Brian Fry and his team conducted a study that rewrote the textbooks. They performed an MRI scan on the head of a preserved Komodo dragon. They were looking for structural anomalies, but they found something far more sinister. Located in the lower jaw were complex, log glands, venom glands. These weren't just salivary glands. Genetic analysis of the fluid inside revealed a cocktail of toxic proteins, known to cause hypertension or low blood pressure, anticoagulation, preventing blood clots, and shock. They changed everything. The Komodo dragon isn't just a big lizard. It's the largest venomous animal on the planet. Here's how the system works, and it's brutally efficient. Unlike a snake, which injects venom through hollow fangs like a hypodermic needle, the Komodo dragon uses a gum ooze method. When it bites, the pressure of the glands forces the venom out of the ducts between the teeth. As the dragon rips and tears at the flesh, the venom mixes with the blood and enters the womb. The effects are terrifying. The anticoagulant toxins prevent the womb from closing, causing the prey to bleed profusely. The hypertensive toxins smash the prey's blood pressure. Imagine standing up too fast and feeling dizzy. That is hypertension. Now imagine that feeling while a 200-pound lizard is eating you. The prey goes into shock rapidly, becoming too weak to fight back or flee. It is a chemical restraint system allowing the dragon to subdue animals 10 times its size, like water buffalo, without getting kicked to death. Digestive physiology. Watching a Komodo dragon eat is a lesson in gluttony. Because they are reptiles with a slow metabolism, they don't need to eat often, maybe just once a month. But when they do eat, they feast. A Komodo dragon can consume up to 80% of its own body weight in a single sitting. To put that in perspective, imagine a 200-pound human sitting down to dinner and eating 160 pounds of steak all in one go. They achieve this through a highly sustainable stomach and hinged jaw that opens extremely wide to swallow large chunks of meat or entire goats whole. Once the food is inside, their digestive system goes into overdrive. Their stomach acid is incredibly potent, dissolving bones, hooves, and hide. But there are some things even a dragon can't digest. Horns, excessive hair, and teeth are indigestible. After digestion is complete, the dragon performs a biological ritual that is truly gross. It regurgitates a gastric pellet. This is a slimy, compressed ball of hair and horns coated in a foul-smelling mucus. The dragon shudders, heaves, and hacks the pellet up, clearing its stomach for the next meal. It is a violent, necessary act of house cleaning for a creature that eats an entire animal, leaving nothing to waste. Intelligence. We tend to underestimate reptiles. We view them as instinct-driven automations, incapable of thought or emotion. But the Komodo dragon challenges that prejudice. In captivity, keepers have reported behaviors that look suspiciously like high-level cognition. Dragons are known to recognize different humans, They know the difference between the keeper who feeds them and a stranger. Even more mind-blowing are reports of play. At the Smithsonian National Zoo, a Komodo dragon named Kraken was observed interacting with objects in ways that had no survival function. The definition of play. She would tug at shoelaces, chase frisbees, and gently mouth objects without trying to eat them. This cattle dog level of intelligence makes sense when you consider their hunting strategy. They don't just sit and wait, they learn. They learn the trails prey animals use. They learn the schedules of humans around them. In the wild, they have been observed anticipating the escape routes of deer. This suggests they possess a cognitive map of their own environment and the ability to plan, traits we usually associate with wolves or crows, not lizards. It turns out that being a giant, venomous killer requires a brain to match the brawn. Metabolism and thermoregulation. As ectotherms, Komodo dragons rely on the sun to power their bodies. They are solar-powered biological machines. This is why you'll often see them basking in the morning sun on rocky outcrops of their islands. They are charging their batteries. This reliance on external heat means they have low energy requirement compared to mammals. A lion needs to eat constantly to fuel its internal furnace. A dragon can wait. But this efficiency comes with a drawback. They have poor endurance. A Komodo dragon can sprint up to speeds of 12 miles per hour for short bursts, launching a terrifying ambush. But they cannot run a marathon. If the initial attack fails, they cannot chase a deer for miles. This is where the venom becomes crucial. The venom bridges the gap between their explosive speed and their lack of endurance. They don't need to chase the prey to death. They just need to land one good bite. Then, the venom does the running for them, slowly draining the life out of the prey, while the dragon tracks it at its own pace. Smelling the blood with its forked tongue, it's an evolutionary workaround, allowing a creature with limited stamina to hunt animals that are designed to run. Science and conflict. The discovery of venom in Komodo dragons didn't just change the textbooks, it started a war. Science is rarely a straight line to the truth. It is often a messy brawl of egos and conflicting data. When Brian Fry published his study on venom, not everybody agreed. Prominent toxologists and physicians argued that just because the dragon had venom proteins in its mouth doesn't mean it's venomous in clinical use. Critics like toxologist Julian White argued that the effects of a dragon bite, such as the bleeding and shock, could be explained simply by the mechanical damage of a huge, serrated teeth ripping through arteries. They argued that calling it venom was just a sensationalist stretch. They pointed out that many humans bitten by dragons survive with simple antibiotics and stitches, without showing signs of systematic envenomation. Fry countered that dry bites, or bites without venom, are common in all venomous animals, including snakes. He argued that the venom is a supporting weapon, designed to lower the prey's blood pressure and induce shock faster than mechanical damage alone. This debate highlights the messy reality of biology. Nature doesn't fit into neat boxes. It's a mechanical killer, or a chemical one. The answer is likely both. The dragon uses every tool at its disposal, teeth, muscle, and toxins, to ensure survival. Conservation crisis. Despite their dominance, the Komodo dragon is in trouble. They live only on a few small islands in a rapidly changing world. Rising sea levels threaten to swallow up their coastal habitats. A changing climate alters their vegetation, impacting the populations of deer and buffalo they rely on. And humans, encroaching on their territory, are shrinking the wild spaces they need to roam. In 2021, the IUCN moved the Komodo dragon from vulnerable to endangered. It is a stark warning. These creatures have survived for millions of years, outliving the megafauna and navigating the rise of humanity. But they are specialists, island dwellers with nowhere else to go. If their islands change, they cannot simply move. Conservation efforts are underway, involving protected national parks and captive breeding programs. But the future of the dragon is uncertain. They are a reminder of a wilder, more primal version of our planet. Losing them would mean losing a direct link to the prehistoric past, a living monster that has earned its place on the throne of the islands. A dragon's gaze. When you look into the dark, slit-pupiled eye of the Komodo dragon, you aren't seeing a monster. You're seeing a masterpiece of survival. You're seeing an animal that has taken a basic reptilian design and pushed it to the absolute limit. They are creatures of paradox. They're cold-blooded, yet they hunt with the fire of a warm-blooded predator. They are armed with the most primitive of weapons, teeth and claws, yet they utilize a sophisticated chemical arsenal. They are solitary killers that possess the capacity for play. The Komodo dragon teaches us that nature is not linear. Evolution doesn't just move forward towards mammals and humans. It branches out, finding successes in the scales and venom of giant lizards as it flickers its forked tongue, tasting the air for the scent of life. The Komodo dragon stands as a defiant guardian of the lost world. It is the last of the true dragons, not of myth, but of flesh, blood, and venom. And its existence challenges us to respect the power of the wild when it looks at us and sees nothing but meat.